let's take a look at this next one. So for each of the following functions, we're going to look at the domain and codomain of 0, 1, 2, 3, 4, and we're going to determine if they are onto functions and show why. So these are small enough that what I can do is calculate f0, f1, f2, f3, and f4. Right? Our domain is small enough that it's easy enough to think about what that looks like. Well, f of x equals x means f of 1 is 1, f of 2 is 2, f of 3 is 3, and f of 4 is 4. And so this is onto. Every element in the codomain 0, 1, 2, 3, and 4 has something coming to it from A. In fact, it goes straight across. So if this is our codomain, we want to show that that's true, but if this is our domain, it's actually coming from 0, 1, 2, 3, 4. There we go. And so that is onto. Now let's look at f of x equals x squared mod 5. And so the question is, can we get to, for each of those values, can we get to the codomain? Well, let's think about what that looks like, because from our domain, from our domain 0, 1, 2, 3, and 4, we can think about what that looks like. Well, f of 0 is 0 mod 5. One, two, three, 4, which is 0. F of 1 is 1 squared, or 1 mod 5, which is 1. So far so good. We're hitting a few of them. F of 2 is 4 mod 5. So far no repeats. F of 3 is 9 mod 5. That is equal to 4. And so we're going to see that all of a sudden we have a problem, because, and we'll see this when we talk about proof later on, but let's see, this is 16 mod 5. And we know that is, if we divide by 5, has a remainder of 1. And so 4 goes to 1. So we can see that there are two elements in our codomain that never have anything coming into them. So it is not onto, and the explanation is exactly that. Both 2 and 3 do not have anything coming into them. So that's a problem. I should have said the problem is not that we have 2 elements coming into 4 or 2 elements coming into 1, but I knew it was a problem immediately because of the fact that I have this, our domain is the same size as our codomain. So if I ever have 2 going into 1, that means I'm missing another one, and that's the real problem there.